So we're gonna do some cool stuff here tonight. Go visit that. Guess there's a object way out in the solar system that's effectively like a planet with sugar on it, which is really weird. Let me get the article up on it here. Oops, that was my square shooter game before I was actually playing that a little bit. It's this guy right here, so let's actually plug this into Chat GPT and we're gonna do a virtual vacation to it. Like, that's gonna be interesting. So let's do our virtual vacation thing and we're going there virtually. Yeah, I guess let's make it in the year 2050, like maybe the earliest that we might be able to actually go there. Probably be a little later than that. Let me turn on comments as well. Oh, interesting. I may not have set the time. This is meant for 8 o'clock here. So, yep, let's start this now. Oops. It's not the right thing. Oh, I'm at 50, but well, yeah, let's go ahead and go 50. Let's just say taking recent articles into account. And that should prompt it to go to the web and get all the information we need here. Let's try that here. Here we go. Cool, so it is actually searching. Yep, it's an object in the Kuiper belt. See if it'll get that right. Make sure the volume's right before I do this. Let's get that way. Here we go.
As we approach 486958 Arrokoth in the year 2050, the view from this distant Kuiper Belt object reveals a fascinating landscape that has captivated scientists and enthusiasts alike. Arrokoth, often described as a due to its double-lobed shape, remains an intriguing subject of study, especially concerning its preservation of ancient ices. The latest research has shown that Arrokoth likely retains its primordial ice, including carbon monoxide and water ice, deep within its structure. This discovery has significant implications for our understanding of how these distant celestial bodies have preserved their volatile components over billions of years. 6th source, 7th source. The surface of Arrokoth is characterized by a mixture of reddish hues, likely due to the presence of complex organic molecules formed by solar radiation. The larger lobe, known as ultima, and the smaller lobe, thula, are connected by a narrow neck, which may have formed from a gentle collision between the two bodies. The surface shows a mix of smooth regions and large mounds, suggesting a history of sublimation and slow erosion driven by the sun's distant warmth. 8th source. 10 source. In 2050, Arrokoth remains a pristine remnant from the early solar system, providing scientists with invaluable insights into the processes that shaped our cosmic neighborhood. Researchers continue to analyze data and develop new models to understand the sublimation induced mass loss that subtly alters the shapes of these icy bodies over time 9 source. As you take in this remarkable view, what would you like to explore next? Perhaps a closer look at the surface features, a dive into the scientific findings about its ice composition, or even a journey to another Kuiper Belt object? Your adventure awaits.
Yeah, so let's actually land on the. And I noticed I put it like on a planet, but it's really like floating in space. But things floating in space there is pretty close. Let me actually show you online what it looks like. And one thing that really fascinated me was there's supposed to be. Let's see, there's supposed to be. They're thinking there's sugar on it. There's like another picture of it that's like reddish, I guess. Let's see if there's a. Okay. There's that they think it looks like in color, I think. So, yep, that's what we're looking at here. So let's land on that band that's between them and explore that. That would be interesting. An interesting place to start. Be interesting to see what the gravity's like there.
You've landed on the narrow neck connecting Ultima and Thule, the two lobes of Arrokoth. The terrain is a fascinating mix of smooth and rough patches with reddish hues. Large mounds and craters dot the surface, showcasing the effects of sublimation and erosion over billions of years. The dark sky, filled with distant stars, accentuates the remoteness of this icy object in the Kuiper Belt. What would you like to do next? Explore the surface, conduct a scientific experiment, or perhaps move to another part of Arrokoth.
So let's observe what the gravity is gonna be like, and yeah, let's observe what the gravity is gonna be like. Man, this would be really neat to do in real life here. Let's see, I'm thinking here. Oh, yeah, let's look at the lobes. Well, let's do it. Check out the gravity, then look at the lobes.
On 486958 Arrokoth, gravity is extremely weak due to its small size and mass. The two lobes, Ultima and Thule, each contribute to the overall gravitational field, but this field is minimal compared to Earth or other larger celestial bodies. Arrokoth's entire mass is estimated to be around 3.1 times 10 to 12 kilograms. Given its size and mass, the gravitational acceleration on its surface is roughly 0.001 meters per squatters, which is about 1/100,000th of Earth's gravity. This means you'd weigh almost nothing and could easily leap and move with minimal effort. However, the unique double-lobed shape of Arrokoth creates some interesting gravitational dynamics at the neck region where you are now. The combined gravitational influence of both lobes might slightly increase the gravitational pull in this area compared to other parts of the surface, but it would still be incredibly weak. Exploring the surface here would be a surreal experience, akin to floating rather than walking. Movements need to be slow and controlled to avoid floating off the surface due to the weak gravitational pull. Would you like to conduct an experiment here, move to another part of Arrokoth, or explore a different celestial body?
Hey there, Wendy. So let me know if there's anything cool you want to do out here. We're way out in the Kuiper Belt on this interesting object called Arrokoth. So it's like this reddish. It's Ultima and Thule. I guess like two. I think it's like asteroids that are kind of joined together. Let me show you an image of what it actually looks like. So, yep, that's what we're visiting right now in the virtual vacations app. So, man, that would be so cool to go explore in real life. So, that's what we're doing here virtually. And let me know if there's anything cool you want to do while we're here. So, yeah, that's really low gravity. That'd be a really interesting view. It's not quite. Well, maybe. I think they'd be like part of it. I think it tried to do it.
From your vantage point on the narrow neck of Arrokoth, you see the two lobes, Ultima and Thule, rising majestically on either side. The larger lobe, Ultima, and the smaller lobe, Thule, both exhibit the same reddish hues and rugged surface textures characteristic of Arrokoth. The terrain here shows clear signs of its tumultuous history, with a mix of smooth and rough areas, large mounds, and numerous craters resulting from sublimation and erosion over billions of years. The dark expanse of the sky, filled with distant stars, highlights the isolation and remoteness of this Kuiper Belt object. The weak gravity makes every movement feel almost effortless, as if you could float from one lobe to the other with minimal exertion. What would you like to do next? Perhaps explore one of the lobes in more detail, conduct a scientific experiment, or journey to another part of the Kuiper Belt.
Hey there, Utes. Yep, we're on Ultimate Thule in the year 2050. It's supposed to be like a sugary, or there's supposed to be sugar on it, which is interesting. It's like ice and sugar, apparently. Show you the images while recap the images here. So, this is what it looks like in real life here. I was like, this would be so interesting to go visit. And this is what Chat GPT or the virtual vacation thing depicted it as. Now we're on it. And then that's an attempt to look at the lobes. I guess that'd be like, it should really be connected there. It shouldn't be like separate planets like that. But see here.
Arrokoth, often referred to as a space snowman due to its double lobed shape, has been a subject of much fascination. Researchers have discovered that it harbors ancient ices, including carbon monoxide and water ice, which have been preserved for billions of years since the formation of the solar system 33C source, 36 source. However, despite its intriguing composition, there have been no findings or evidence suggesting the presence of sugar or similar organic compounds on Arrokoth. The surface of Arrokoth is known for its reddish hue, primarily due to the presence of complex organic molecules, known as anistolins, which are common on many Kuiper Belt objects 35 by source, 37 source. If you're interested in learning more about the chemical composition and the latest discoveries regarding Arrokoth, feel free to dive into the detailed studies conducted by NASA and other scientific bodies. There's 36 source. What would you like to do next? Perhaps explore another area on Arrokoth, conduct a specific scientific experiment, or venture to a different celestial body.
So I guess that's disappointing that apparently there's not sugar on it. Let's see. So I guess it's Arrokoth's made up of Ultima and Thol. I guess I'm not sure how big. Actually, while it's making that, let's go see how big it is. Oh, 36 kilometers. So yeah, you could. Okay, 22 miles. Okay, cool. Oh, this is kind of cool.
As you start your ascent up the larger lobe, Ultima, of Arrokoth, the landscape unfolds with a fascinating mix of smooth and rugged terrains. The reddish hues dominate the scene, a result of complex organic molecules known as tholins. Large mounds and craters are scattered across the surface, each telling a story of the ancient processes that shape this distant Kuiper Belt object. The weak gravity makes the climb feel almost effortless, allowing you to take large, bounding steps. The horizon reveals the narrow neck connecting Ultima to Thule, the smaller lobe, with the vast expanse of space and distant stars serving as a breathtaking backdrop. What would you like to do next? Continue exploring Ultima, examine a specific feature, or perhaps head towards Thule?
So let's look at Thol from this vantage point. See if it comes up with something reasonable. I think like you'd see like the landscape kind of descend and then ascend. Okay, no, but didn't quite get it right.
From your vantage point on Ultima, you look towards Thule, the smaller lobe of Arrokoth. The narrow neck connecting the two lobes is clearly visible, showcasing the unique double-lobed shape of this Kuiper Belt object. The surface features a mix of smooth and rough terrains with the characteristic reddish hues, large mounds, and craters scattered throughout. The dark sky, dotted with distant stars, provides a stunning backdrop, highlighting the remoteness of this icy world. What would you like to do next?
So
Continue
we're doing
exploring the
a
surface of
virtual
Ultima,
vacation
move
on
towards
Arrokoth.
Thule,
So I'm
or
using
perhaps conduct
a
a
virtual
specific scientific
vacations
experiment.
chat GPT thing that I made actually, and you can go anywhere, anywhen, pretty much. So we're exploring Arrokoth in the year 2050. And welcome, by the way. So this is the thing we're exploring here. And it's actually reddish. Oh yeah, there's a better picture of it there. I heard an article say that there's sugar on it effectively, or this ultraviolet light converted some of the organic compounds into sugar, but that may have just been a sensationalist claim, I guess. Like, seems like Chat GPT is thinking that that's not true, and I trust Chat GPT over like a single article, I guess. So if multiple articles are saying that, then yeah, I don't know. So there may or may not be sugar on there. It seems like ChatGPT just kind of saying maybe not. I guess. Interestingly enough, I am kind of curious what's in the organic compound, so let's sample them and check them out on the ship. Or analyze them on the ship. That's a better way to. Man, it's really misunderstanding me a bit.
You gather a sample of the reddish surface material, rich in organic compounds, from Ultima. Carefully placing it into your collection container, you make your way back to the ship to analyze the sample. Once aboard, the onboard lab's instruments begin to analyze the organic compounds. The analysis reveals a complex mixture of tholins, organic molecules that form through the irradiation of simpler compounds like methane and ethane. These tholins are responsible for the reddish coloration observed on the surface of many Kuiper Belt objects, including Arrokoth. Analysis results. Tholins, the primary organic compounds, which form from solar radiation interacting with methane and nitrogen ices. Methane, CH4, present in smaller quantities, a building block for tholins. Ethane, C2H gas, another component found in the sample, contributing to the formation of tholins. Nitrogen, traces of nitrogen found within the sample, also playing a role in tholin formation. These findings provide valuable insights into the composition and chemical processes occurring on Arrokoth, offering a glimpse into the conditions of the early solar system. What would you like to do next? Continue exploring other parts of Arrokoth, conduct another experiment, or venture to a different celestial body?
Oh, let's eat some and see what happens. See what it tastes like. That's really funny. Wouldn't recommend that in real life. That we're virtual here. We can do whatever we want, basically. No, it's not advisable. Okay.
It is not advisable to ingest any extraterrestrial substances, including the organic compounds found on 486958 Arrokoth. These compounds, although interesting for scientific analysis, could be harmful or toxic. Instead, I can provide a detailed scientific analysis of the compounds, which has already indicated the presence of tholins and other organic molecules. Tholins, for example, are complex organic substances formed by solar ultraviolet irradiation or cosmic rays on simple organic compounds like methane or ethane. They are not edible and could be dangerous if ingested. For a safe and educational exploration, we could simulate the experience or focus on another scientific experiment related to the findings on Arrokoth. What would you like to do next? Continue exploring Arrokoth, conduct another experiment, or venture to a different celestial body?
Ooh, it'd be interesting to tunnel into it. Let's do that now. So let's go back to the deck where between Ultima and Thol, and then tunnel into it. That's funny. Let us eat it. No. Do some really interesting gravity stuff here too, because there's not much gravity at all.
As you tunnel into the narrow neck between Ultima and Thule, you uncover a fascinating cross section of Arrokoth's composition. The tunnel reveals layers of ancient ice, intermixed with the reddish organic compounds that characterize the surface. The rough terrain inside shows the history of sublimation and erosion that has shaped this Kuiper Belt object over billions of years. The dark sky, filled with distant stars, is visible through the tunnel entrance, adding to the sense of exploring an untouched world. Inside the tunnel, you find ancient ice. The ice layers contain a mix of water and carbon monoxide, preserved from the early solar system. Tholins, complex organic molecules formed by the interaction of solar radiation with simpler compounds like methane. Porous rock. The interior structure includes porous regions, which likely play a role in retaining the volatile ices. This exploration provides a deeper understanding of the composition and history of Arrokoth, offering clues about the conditions in the early solar system. What would you like to do next? Continue exploring the tunnel, conduct a specific analysis, or venture to another part of Arrokoth?
Looks like we dug quite the tunnel there. Actually, I guess that could be halfway accurate there. Like if we're kind of like on the neck and we're kind of like on one side looking at the other side. So that's pretty interesting. But yeah, I think I'm gonna save that one. That's pretty cool. So I guess we really dug a tunnel there. Okay, so maybe we could do some gravity experiments now. Actually, let's go deeper. Let's see what happens if we dig to the core, I guess. Let's see what it thinks the core would look like. It'd be quite a undertaking. Like 10 plus kilometers, like maybe 10 miles or so. And with low gravity and not much pressure and heat, we might be able to do something like that. Well, that'd be pretty hard.
As you dig deeper into the core of Ultima, the larger lobe of Arrokoth, you uncover a fascinating interior. The layers transition from the reddish surface material to ancient ice and porous rock, each stratum revealing more about the history and composition of this distant Kuiper Belt object. At the core, you find a compact mixture of ice and organic compounds. The ice here is more solidified and interspersed with darker, more complex organic materials, indicating that it has been well preserved from the early days of the solar system. The unique texture and coloration of the core materials suggest minimal disruption over billions of years, offering a pristine glimpse into the conditions that prevailed during the formation of Arrokoth. Artificial lights illuminate the scene, casting eerie shadows and highlighting the intricate details of the core. The dark sky with distant stars is still visible through the tunnel entrance, providing a stark contrast to the ancient ice and rock inside. What would you like to do next? Conduct a detailed analysis of the core sample, explore another part of Arrokoth, or venture to a different celestial body.
Man, that's pretty cool. So I guess that'd be literally a core sample. Sample of the core. Like I guess the core sample's not usually the sample of a core. Like we can't dig to the core of the earth, but it's interesting. Let's see here. Let's see how high we can jump.
Given Arrokoth's extremely low gravity, your jump from the bottom of the hole at the core to the surface would be an extraordinary experience. The gravity on Arrokoth, is about 0.001 meters per second squatters, which is around 100,000th of Earth's gravity. This weak gravity allows for impressive leaps with minimal effort. As you push off from the bottom of the hole, you feel almost weightless. With a gentle jump, you ascend slowly and smoothly, easily clearing the distance to the surface. The lack of strong gravitational pull means your ascent is leisurely, giving you plenty of time to observe the layers of ice and organic compounds as you pass by. Reaching the surface, you land softly, barely feeling the impact due to the weak gravity. This remarkable leap highlights just how different movement is in such a low gravity environment, offering a unique and exhilarating experience on this distant Kuiper Belt object. What would you like to do next? Continue exploring the surface of Arrokoth, conduct another scientific experiment, or perhaps venture to another celestial body.
Wow, wouldn't that be cool? Like jump 10 miles from the bottom at the Earth, or I mean, at the gravity's that weak. You may be able to actually jump all the way out of the hole. See what the escape velocity of Thor or of this of Arrokoth is. Oh, very good. And that's how fast it would take to, or like how fast you'd have to go to escape its gravity all the way, like go back out into space all the way, not fall back down to it. 0.16 meters a second. Okay. So yeah, it'd be very small. Okay, cool. So actually, our jump would have probably taken us, unless we just very weakly jumped. Jump would probably make us escape the body entirely. That's crazy. So yep, you'd easily be able to leap from its surface and go into space. Let's try throwing a rock, and we'd probably be able to throw a rock into space.
Given Arrokoth's extremely low escape velocity of approximately 0.16 meters per second, throwing a rock upwards would yield some interesting results. If you throw 0.16 meters per second, it will escape Arrokoth's gravitational pull and continue traveling into space. Simulation. 1. Preparation. You pick up a small rock from the surface. 2. Throwing. You throw the rock upwards with a speed greater than 0.16 meters per second, which is quite easy to achieve since it's much slower than a typical human throw on Earth. 3. Observation. Initial ascent. The rock ascends slowly, passing through the thin atmosphere, if any, and the layers of the surface. Midway, it continues upwards, losing speed gradually due to the weak gravitational pull. Escape. If the throw exceeds 0.16 meters per second, the rock doesn't fall back. Instead, it continues moving away from Arrokoth, eventually drifting into the vastness of space. Analysis. If thrown below 0.16 meters per second, the rock would ascend and then fall back to the surface, similar to how objects behave under Earth's gravity, but in a much slower, more floaty manner. If thrown above 0.116 meters per second, the rock escapes Arrokoth's gravity, demonstrating the low escape velocity and minimal gravitational influence of this Kuiper Belt object. This simple experiment highlights the unique physical dynamics on such a small and distant celestial body. Would you like to continue exploring more activities or scientific experiments on Arrokoth, or perhaps venture to another celestial body?
Oh, I got a funny idea. Let's see if we can jump by passing gas. Okay.
Considering Arrokoth's extremely low gravity, it's feasible to explore the concept of propulsion using bodily functions, albeit in a humorous context. The idea is to create a small, directed thrust using the gas expelled from the body. On Earth, this wouldn't have any noticeable effect due to our strong gravity. However, on Arrokoth, with its escape velocity of just 0.16 meters per second, even a minor thrust could have a more significant impact. Scenario 1. Positioning. You crouch down and prepare to release gas. 2. Release. Upon releasing the gas, you feel a slight push. 3. Effect. The weak gravity means that this minor propulsion could indeed lift you off the ground slightly. The effect would be akin to a gentle hop or float, emphasizing how minimal forces can cause noticeable movements in such a low gravity environment. Analysis. Thrust mechanics. The principle at play here is similar to that of a rocket. Expelling gas in one direction propels you in the opposite direction. Newton's third law of motion. Practicality. While this is a fun thought experiment, in reality, the amount of thrust generated by such a small force would be very limited, but sufficient to lift off momentarily due to the minimal gravitational pull. This playful experiment highlights the intriguing dynamics of movement in microgravity environments like Arrokoth. What would you like to explore or do next?
Y'all have any good ideas? That was pretty funny there. Oh, let's show it. Let's see a picture of it. Oh, this could be epic. Feel free to like and subscribe, by the way. Oh, man. Oh, man. Oh, man. Oh, man. Okay, that's about the funniest thing I've seen. This is probably the funniest thing I've seen on virtual vacation so far. Yep, we're saving that. That's pretty epic. Oh man. Oh boy.
Here's a humorous image showing a person being gently lifted off the ground on Arrokoth due to passing gas. The low gravity allows for a slow, gentle ascent, illustrating the minimal forces needed to cause noticeable movement on this Kuiper Belt object. The surface around features reddish hues, large mounds, and craters, with the dark sky filled with distant stars, highlighting the remoteness of Arrokoth. What would you like to do next? Explore more activities on Arrokoth, conduct further scientific experiments, or travel to a different celestial body?
And funny enough, I guess I'd really just get trapped in your spacesuit though, and probably wouldn't do anything really other than that. Oh, you probably have a rough time. I wonder how they deal with that in real life with astronauts. Like if you fart when you're on a spacewalk, do you have like you have to smell it the whole time or whatever. It's an interesting thing. I don't know if they can filter it somehow or what. But that is an interesting question. What happens if you fart in a spacesuit? So. Anyway, yeah, let's get back to exploration. Oh, you could probably see how big of a rock we can lift. Probably lift a huge. You could probably really lift a huge one. Probably almost carry a mountain.
On Arrokoth, given the extremely low gravity, you can lift much larger rocks than on Earth. The gravitational acceleration on Arrokoth is about 0.0001 meters per second quadratus, which is around 100,000th of Earth's gravity. Calculation. To determine the weight of a rock that
Wow,
can
it weighs
lift,
10
let's
million
compare it to Earth motion.
kilograms.
If you can lift a
Wow.
100 kilograms rock on Earth, the force required is F text Earth, M times G text Earth equals hundredths, K degree times 9.81, text M for squares 981, text N. On Arrokoth, the same force can lift a rock with a much larger mass because the gravitational acceleration is so low. M or text Arrokoth equals frac F for text Earth, Arrokoth, 981 text N, 0.0001, 9,810,000? So theoretically, you could lift a rock that has a mass of up to 9,810,000 kilograms on Arrokoth with the same effort it takes to lift 100 kilograms on Earth. Practically, the size and volume of the rock would be limiting factors, but this calculation shows the remarkable difference due to the low gravity. Would you like to see an image illustrating lifting a large rock on Arrokoth? Here's an image showing the experience of easily lifting a very large rock on Arrokoth due to its extremely low gravity. The minimal gravitational pull allows for effortlessly moving objects that would be incredibly heavy on Earth. The surface features reddish hues, large mounds, and craters, with the dark sky filled with distant stars, highlighting the remoteness of this Kuiper Belt object. What would you like to do next? Continue exploring Arrokoth, conduct more scientific experiments, or travel to another celestial body?
Funny enough, I think it'd throw you back way more than it throws the rock. That's interesting. Let's see if it would. Let's see if it does that. Let's see if it shows it. If it grasps it. If not, then maybe we can. Actually, if you had your feet planted, if you're counteracting the throw, it may stand still. Let's see what it says.
Here's an image capturing the experience of throwing a very large rock on the surface of Arrokoth. The extremely low gravity allows the rock to ascend slowly, illustrating the minimal gravitational pull. The reddish surface, large mounds, and craters provide a stark contrast to the dark sky filled with distant stars, highlighting the remoteness of this Kuiper Belt object. What would you like to do next? Continue exploring Arrokoth, conduct further experiments, or travel to another celestial body?
Something messed up there.
Yes.
Second.
If you throw a rock that weighs more than you, in the low gravity environment of Arrokoth, the physics principles involving conservation of momentum dictate that you would be pushed back more than the rock. Conservation of momentum. In physics, the law of conservation of momentum states that in a closed system, the total momentum before and after an event must be the same. When you throw a rock, both you and the rock form a closed system. The momentum you impart to the rock must be equal and opposite to the momentum imparted to you. Momentum calculations. 1. Momentum P is defined as the product of mass m and velocity v. P equals m times v. 2. Initial momentum. Before the throw, both you and the rock are stationary, so the total initial momentum of the system is 0. 3 after the throw. Let's denote your mass as m1 and the mass of the rock as m2. If you throw the rock with a velocity v2, your velocity v1 will be in the opposite direction. According to the conservation of momentum, m1 times v1 minus m2 times v2. Therefore, v1 equals frac m2 times v2 m1. Given m2, the rock's mass, is greater than m1, your mass, your resulting velocity v1 will be larger compared to the rock's velocity relative to your masses. Example, assume your mass m1 is 70 kilograms and the rock's mass m2 is 140 kilograms. If you throw the rock with a velocity v2 of 0.1 meters per second, v1 equal minus frac 40 times 0.1, 70 equals minus 0.2. This means you would move backward at twice the velocity of the rock. Visualization. Given the low gravity on Arrokoth, this effect would be more pronounced. The minimal gravitational pull would allow even a small force to result in significant movement, making this a dramatic demonstration of the conservation of momentum. Would you like to conduct more experiments, explore other areas on Arrokoth, or travel to a different celestial body?
See, and y'all got any thoughts? Oh, let me make sure I have comments enabled. You have comments are enabled. Okay. So let's see. What do we want to do next? Oh, let's ask it about that article. I don't remember where I saw that. I think I saw it this morning. It may have even been on YouTube, which I guess funny enough. Well, I say this while I'm here on YouTube. It seems like you can't totally trust stuff on YouTube. Well, it depends on the source. Like PBS Space Time's pretty good, or like really good actually. And if it's just some random space thing, may or may not be accurate, I guess. But let's see. Oh, there are. Okay, cool.
Recent studies have indeed discovered the presence of sugar compounds on 486958 Arrokoth. According to a 2024 publication, simulations of Arrokoth's red surface suggest it is rich in sugars formed through exposure to ionizing radiation. This discovery was made by a team of scientists from institutions such as the University of Hawaii and the SETI Institute 109 source. This finding has significant implications for our understanding of the chemical processes that occur in the outer solar system. It suggests that organic molecules, including sugars, can form and be preserved on these distant objects, offering clues about the early solar system's conditions and the potential for complex chemistry beyond Earth 111 source, 111 source. Therefore, the articles reporting the presence of sugars on Arrokoth are based on legitimate scientific research and are not merely sensationalized claims. This discovery marks an exciting advancement in our understanding of Kuiper Belt objects and their composition's 130 source. Would you like to continue exploring Arrokoth, conduct another experiment, or venture to a different celestial body?
So there is sugar here, at least as far as we know as of recent. So okay, that's awesome. Okay, let's mine some of it, and then let's make some coffee with it. Yeah, we'll put it in our coffee. Take take it back to the ship and make some coffee with it. Add it to our coffee. Okay. I don't know if it's the same type of sugar. Like, I don't know if it's actually like edible sugar, if it's like something else.
Here's an image showing the process of mining sugar compounds on the surface of Arrokoth. The mining equipment digs into the reddish surface, revealing layers of ice and reddish material. The extracted sugar crystals glisten in the low-gravity environment, emphasizing the unique conditions on this distant Kuiper Belt object. The dark sky filled with distant stars adds to the sense of remoteness and exploration. Would you like to continue with more activities on Arrokoth, conduct further scientific experiments, or travel to a different celestial body?
Okay, let's go take it back and make some coffee with it. See what happens. Like, if it may be not advisable because it's not actually sugar. Oh,
You collect some of the extracted sugar compounds and head back to your ship. In the ship's galley, you brew a fresh pot of coffee. Adding a bit of the mined sugar to your coffee, you stir and take a sip. Taste sugar crystals dissolve quickly, leaving no residue. 2. Flavor. The sugar adds a subtle sweetness to the coffee, with a hint of unique aftertaste, possibly due to the specific composition of the organic molecules. 3. Experience. The low gravity environment makes the entire process of brewing and sipping coffee an unusual but enjoyable experience, with the added novelty of using extraterrestrial sugar. This experiment highlights the potential for utilizing resources found on distant celestial bodies, enhancing the human experience in space exploration. Would you like to continue exploring other activities on Arrokoth, conduct further experiments, or venture to a different celestial body? Here's an image capturing the moment of brewing coffee inside your spaceship and adding the unique sugar extracted from Arrokoth. The coffee cup shows the sugar crystals dissolving, while the spaceship's interior and a view of the stars outside the window enhance the ambiance of this extraordinary experience. Would you like to continue exploring other activities on Arrokoth, conduct further experiments, or venture to a different celestial body? Here's an image showing the detailed view of the organic compounds extracted from Arrokoth under a microscope. The intricate structures and textures of the compounds are displayed on the screen, providing a fascinating glimpse into the complex chemistry of this distant Kuiper Belt object. The spaceship's interior, with a view of the stars outside the window, adds to the sense of exploration and discovery. What would you like to do next? Continue exploring other aspects of Arrokoth, conduct further experiments, or travel to a different celestial body?
ooh, I wonder if this would actually be a good place. Like, if we could actually, like, if it's got ice and sugar, like, there might be our food and water, basically. Like, and if we're inside it, we might be able to actually live there. That'd be interesting. I'd probably provide protection from stuff, but I guess you'd have to do heating. You'd have to provide your own heat somehow, but and your own air. Actually, not. I would say here. I don't remember how it's spelled exactly. No, it's called Arrokoth. So I think heat would be our main challenge here. Sugar might help with our food, and then the water would help with our. Well, I think there's water there. Let's see. Yeah, like ice, frozen water, I think.
Building a base under the ice on 486958 Arrokoth presents unique challenges and opportunities. Here's an exploration of the feasibility regarding air, food, water, and radiation protection. 1. Air supply. Production. Generating breathable air in space habitats typically involves splitting water into oxygen and hydrogen using electrolysis. If Arrokoth's ice contains water, H2O, it can be a source of oxygen. Filtration. Systems similar to those on the International Space Station IS can be used to recycle carbon dioxide and other waste gases, converting them back into oxygen. Water supply. Extraction. The presence of ancient ice on Arrokoth means that water can be extracted by melting the ice. Advanced filtration systems would ensure the water is safe for consumption and other uses. Recycling. Water recycling systems, as used on the ISS, can purify wastewater from various sources, including urine, to provide a sustainable supply of water. 3. Food production. Hydroponics, aquaponics. Growing food in space requires hydroponic or aquaponic systems. These systems can be set up within the base, using artificial lighting and nutrient solutions to grow vegetables and other plants. Supplementation. Initially, food supplies would be brought from Earth. Over time, a sustainable agriculture system could reduce dependence on resupply missions. 4. Radiation protection, ice shielding. The ice and surface material of Arrokoth can be used as a natural shield against cosmic radiation. Building the base beneath several meters of ice would provide significant protection. Materials. Additional shielding materials such as polyethylene, water, or regolith can be used to enhance protection against solar and cosmic radiation. Feasibility assessment 1. Resources availability. Water ice. The presence of ancient ice is confirmed, providing both water and oxygen, one at one to love source. Organic compounds. These can be studied for potential use in life support systems or even food production. 109 source, 110 source. 2. Technological requirements. Existing technology for air, water recycling, and food production in space can be adapted for use on Arrokoth. Advanced robotics and autonomous systems would be crucial for constructing and maintaining the base in such a remote location. 3. Environmental challenges. Low gravity. The low gravity environment would affect both construction and day-to-day activities. Specialized equipment and techniques would be necessary to handle materials and maintain structural integrity. Temperature extremes. Extremely low temperatures would require robust thermal control systems to ensure a habitable environment. Conclusion. Building a base under the ice on Arrokoth is technically feasible with current and near-future technology. The presence of water ice provides a crucial resource for life support, while the ice itself can be used for radiation shielding. Sustainable food production would take longer to establish, but is achievable with hydroponic systems. Overall, with thorough planning and the development of specialized technologies, a human habitat on Arrokoth could be a reality. Would you like to proceed with more detailed planning or explore another aspect of space exploration?
Man, that's exciting. I just got goosebumps from that. Wow. Like, I wonder if we might set up a mission to do that. That'd be funny if we colonize Arrokoth before we colonize Mars, even, or whatever. Like, imagine we'll go to Mars probably first, but looks like that might be a feasible place to set up a base. Guess you'd have gravity, but you could do like have rotating rooms or something. Yeah, you wouldn't have much gravity, but you could do that. I think structural integrity probably wouldn't be much of a challenge without gravity. I think it's more of a challenge with gravity, I guess. You would have to hold the pressure of like you'd have to be able to like just like anywhere in space, you'd have to be able to contain the air in the structure, I guess. But we done that with the International Space Station and our spaceships, so we can do that. So, any thoughts or questions before I end it for tonight? I think that was pretty cool here. Yeah, at least I liked it. And yeah, feel free to like and subscribe and do these Mondays, Wednesdays, and what I have been doing on Fridays. I may switch it up to Thursdays. At least do on Mondays and Wednesdays, going through the countries mainly, and do the countries, the United States, and the different bodies in the solar system. So, yeah, feel free to check out my virtual vacations playlist, which this is going to be a part of here shortly. Yep, thank you for watching. Feel free to, yeah, I hope you have a great day or night. Actually, it's night here. I'm about to go to bed here, so have a good one.